Next, we're going to talk about the remainder theorem, which leads us to the factor theorem. What is the root of a polynomial? The root is the x value that makes y equal to 0, or it is the x-intercept. It's the value of the variable that makes the polynomial equal to 0. Is 4 a factor of 5,264? You find out if something is a factor by dividing. So we take 5,264 and divide it by 4. There's the most important part right there. If the remainder is equal to 0, yes, 4 is a factor. So it's very important to know what the remainder is, because if it's equal to 0, you have a factor. The number 4 is a factor of 5,264 if and only if the remainder, when divided by the number 4, equals 0. Now we want to know if x plus 3 is a factor of x squared plus 7x plus 12. So we're going to use polynomial division. X squared divided by x equals x. First step is divide. Next step, multiply. X times x, x squared. X times 3, 3x. So we divide, then we multiply. Next step, subtract. In order to subtract a polynomial, we actually have to distribute the negative. So I want to subtract, so I distribute the negative into both terms. Now we can subtract. X squared minus x squared cancels. 7x minus 3x is 4x. Bring down the 12. 4x divided by x. I take this and divide it by this, and I get 4. So that goes up here. That was the divide step. Next step, multiply. 4 times x is 4x. 4 times 3, 12. Next step, subtract. Distribute a negative. 4x minus 4x cancels. 12 take away 12, 0. If the remainder is 0, yes, x plus 3 is a factor of x squared plus 7x plus 12. Now, some of you may have recognized that at the beginning because you know that you can factor x squared plus 7x plus 12 into x plus 3 and x plus 4. Next, we're going to take 2x to the 4th minus 3x squared plus 4x minus 9 and divide it by x plus 2. And we want to know, is x plus 2 a factor? This time we're going to use synthetic division. Step 1, bring down the 2. Next step, multiply the 2 and the negative 2. Add down. Multiply the negative 4 and the negative 2. Add down. Multiply the 5 and the negative 2. Add down. Multiply the negative 6 and the negative 2. Add down. Therefore, 2x to the 4th minus 3x squared plus 4x minus 9 divided by x plus 2 is 2x to the 3rd minus 4x squared plus 5x minus 6, remainder 3, or plus 3 over x plus 2. So the remainder was 3. Is it a factor? No. In order for it to be a factor, we need a remainder of 0. Next we're going to use the remainder theorem. The remainder theorem says to see what the remainder is when you divide two polynomials, you plug in the opposite of that number right there. So I'm going to plug in negative 3. So stop the video, substitute negative 3, and let's see what you get. So I plugged in negative 3. Negative 3 squared is positive 9. Those negatives are going to cancel. I add those together, and I get 0. So the remainder theorem is a shortcut. Instead of doing long division, we're going to substitute the opposite of that number right there. So using synthetic division, we got remainder equals 3. Let's use the remainder theorem. The remainder theorem says to find out what the remainder is, you plug in the opposite of this number right here. So we're going to plug in negative 2. Pause the video, plug in negative 2, simplify, and let's see what you get. Notice when I plug in a negative and I have an even exponent, I get a positive number. So I get 32 take away 29 is equal to 3. And when we use synthetic division, we got r equals 3. Next question. Is x plus 2 a factor of this polynomial? No, it is not a factor. So what is the remainder theorem? It is a shortcut. If you only need to know the remainder, you don't need to do the long division. You can use the remainder theorem by plugging in the opposite of this number right here. Notice the remainder theorem only works if you're dividing by a linear binomial. So now I want to know, is x minus 2 a factor of the polynomial? And this will help us know, is the number 2 a root of the polynomial? So I could do long division, but I don't need the quotient. All I need is the remainder. So I don't need to do long division. Instead, I'm going to use the remainder theorem. So what am I going to plug in? I'm going to plug in the opposite of negative 2. I'm going to plug in 2. Pause the video and simplify. So I'm going to get 42 minus 42 is equal to 0. Is x minus 2 a factor of the polynomial? Yes. How do we know that? We got a remainder of 0. Is 2 a root of the polynomial? Yes. X minus 2 is the factor, 2 is the root.